considering the case of tank filling problem. So this case of cumulative accumulation inside a tank. So let us define the problem mentioned here. So the rate of accumulation dq by dt is given as 1 liters per minute, and the total time for accumulation is total time for accumulation. So it is given as 5 minutes. So it's a very simple problem. So after you can very easily understand that after 5 minutes 5 liters will be filled. So let us analyze this problem mathematically, and we'll try to understand the concept of integration. So here I can solve this problem by direct integration by exact method. So that I can do it as dq is equal to dq by dt into dt. So here this is dq by dt is a rate function. So this is the rate of accumulation. So this is the rate of accumulation. So the unit is liters per minute. So here in this graph, two functions are given. So one is the volume function. So what is the volume function? So, which is in liters. So this is the collected volume function, which is given in liters. The next function given here is the rate of accumulation. So that is dq by dt. So two graphs are formed. Okay. So the volume is in liters, and the rate of accumulation is in liters per. Okay. So we are trying to understand the case of cumulative accumulation by integration. So let us integrate this function and find the cumulative accumulation. So this I can write it as dq is equal to a dt, because for our case integration is constant. Okay, so this is equal to k, this is equal to 1. Okay, so this is equal to 1. So q is given by integral of 0 to e a d. Okay. So here for our case it is 0 to 5 minutes, and the k is 1. So just now we have seen the rate of accumulation is 1 dt. Okay. So now I can do this integration. So I will be getting the t. The integration of dt is 2. So the limit is 0 to 5. So I get 5 minus 0, so that is 5. So 5 liters is the answer for this. Okay. So this we have got by direct integration. So next we are going to find the same solution by Riemann integration. That is by numerical. Okay. So in the numerical method, we are going to use the principle of cumulative accumulation. The numerical method by Riemann integration step. So we are going to use the method of cumulative accumulation. So for that, the expression I have q of n plus 1 is equal to q of n plus dq by dt into okay, and we know that the dq by dt is the rate of accumulation, which is given by k, which is equal to 1. So based on that, we are going to find the values at the respective points by numerical methods. So now, first case we will consider the accumulation problem, the integration problem. Our domain is between 0 to 5. That means we are having a total of 5 minutes. So we have a total of 5 minutes. And for that, how much is the accumulation? That is what we are going to discuss. So we have defined the problem with dq by dt is equal to k, which is equal to 1. So that is what we have assumed in our problem. Now we are going to divide this. Okay, so total time is 5 minutes, and we are going to divide that into 1 minute. Okay, so divide by 1 minute. So we will be having 5 divisions. So here we can see there are 5 divisions. Okay, so this is 1, 2, 3, 4, 5 divisions are there. So each interval is delta t. Okay. So now we can carry out numerical integration using the Riemann rectangle strips. So here we are using the upper Riemann integration strip. So the first case q naught will be equal to 0. Okay, so q naught is equal to 0. So that is what we are having here. And next case, and here we are using a left Riemann integration strip. So that is why we are getting the first initial value as 0. Okay. So if you are having a center Riemann integration strips, so the initial q naught value will be 0.4. So that also we have to know. And even if you are using a right Riemann integration strip or a lower Riemann integration strip, so then your q naught value will be equal to 1. Okay. So it depends on the type of Riemann integration strip what you are using. So the initial value is 0 here, plus we are using left Riemann strips or upper Riemann strips. So accordingly we have q naught is equal to 0. Next using Taylor series we are calculating this value. So q1 is q naught plus dq by dt delta t. So in this dq by dt we have assumed that as constant, which is equal to 1. So that value we are getting here. Q naught is 0. So delta t is 1 because 5 divided by 5 divided by 5 will be 1. 5 minutes divided by 5, which is this 1. So 1. So this is also 1. So I have the value of q1 is 1. So next using q1 we have to calculate what is q, because we are discussing about cumulative accumulation. So So we go to Q2. So Q2 is Q1 plus dq by dt to delta t. So again, this is k, which is constant, is equal to 1, and this delta t is equal to 1, and initial value is 1, 1 plus 1 value. So Q2 is 2. So here you can see that there is accumulation of flow. Okay. So next we are going for Q3. So Q3 is Q2 plus dq by dt to delta t. So Q2 is 2, and dq by dt is k, already we know, which is equal to 1, and delta t is 1, so the value Q3 is 3. Okay. So here you can see Q3 is 6. So slowly we are seeing that each time step our volume flow is getting up. So next we are calculating the final volume. So that is Q4. Q4 is Q3 plus Q by dt to delta t. And again with the same procedure, dq by dt and delta t of 1. So initial value is 2, that is 3. So both together we are getting 4. So 4 is the cumulative accumulated. So, but you know that here we are carried out integration. So and we have found out the value of integration as 5. So that is a theoretical exact value, and that is accurate value. Okay. And now we have found out what is the Riemann integration formula value. So Riemann integration formula value is 4, and the difference between these two, the difference between these two is the error. Okay, so 5 minus 2. So we have so here also you can see actually we have got the value as 5, but the actual value what we have got by Riemann integration is 4. So the difference between these two, that is 1. So this is error value. So now we can proceed with the simple integration with a different value of delta t. So naturally for reducing the error, you can understand that we have to reduce delta t. So next we are going for delta t is equal to 0.5. Okay. So total time is 5 minutes. So delta t is 0.5. So totally we will be having 10 divisions. Okay. So we will be having 10 divisions, and for each division we will do the division. So here you can see that. So each division will be having a length of 0.5. Okay. So each division will be having a length of 0.5, and for each division we will do the calculation. So as discussed in previous case, do not will be 0. As usual, do not will be 0 because we are tallying on the left integration or upper integration. So using Taylor series we are going to further. So like the previous case, k is same. Okay, so dq by dt is k, which is equal to 1. That is same. So that value I have substituted here. But the delta is changed. Delta t is changed. The value is 0.5. So accordingly, q1 will be 0 plus 0.5, which is 0.5. Okay. So here you can see the calculation is 0.5. So q1 is 0.5. Okay. So next we can go for calculation of q2. So q2 again the same formula, q1 plus q by dt to delta t. So this is k, and this is equal to 1. So that substitute delta t is 0.5. Previous value is 0.5 plus 0.5 is equal to 1. So now you can see that q2 is equal to 1. So next third step, again the same formula. Q3 is q2 1 plus dq by dt is 1 to 0.5. So it is 1.5. Okay, so q3 is 1.5. So now slowly we can see the cumulative accumulation. Okay, inside that time. So next it is q4. So q4 is q3 plus value. So that is 1.5 plus 1 into 0.5. 0.5 is delta t. Okay. So which is equal to, so q4 is equal to. Next we have q5. So q5 is 2 plus 1 into 0.5 is 2.5. So q5 is 2.5. And in the same like we can calculate on the other cases. So q5 is 2.5 plus 0.5. So that is 3. So 2 is 3. Next we have q7. Q7 is q6 plus dq by dt to delta t. So q6 is 3, and this value multiplied is 0.5, so that is 3.5. So q7 is 3.5. So now you can see that we are slowly calculating the cumulative accumulation mathematically. So next is q8. Q8 is q7 plus dq by dt to delta t, which is 4. So q8 is equal to 4 liters. Next the last value, so that is given by q9. Q9 is 4 plus 1 into 0.5, that is 0.5. 4 plus 0.5 is 4.5. So q9, this is the cumulative accumulated last value. So this is equal to 4. And here you can see as usual our theoretical value is 5. By using integration our theoretical value was 5. But in this case our q Riemann is 4.5. So the error is 5 minus 4.5. This one. So this is the error. case, we get the total time as 5 minutes. So we are dividing that by delta t point. So totally we are having 5 divisions. Okay. So that we are calculating the two values multiplication. So we start with not this square. Q1 is given by Q0 plus Q2 by Pt equal delta t. So next we are calculating Q2 is equal to Q1 plus Q2 by Pt equal to delta t. So likewise, we keep on continuing, and we are calculating Q24. Okay. And this value, so we have calculated out 24. That is how we have obtained this is Q24. That is a limited value. So in our theoretical value, it is 5. Okay. So the theoretical value is 5, and the Riemann value it is 4.8. So accordingly, we have error. So the difference between these two is error. So this is error. This is given by 0.2. And here what is that we are finding is as I increase the number of intervals, my accuracy is improving, the error is reduced. To understand this, further you can reduce the delta t and improve the accuracy. And the next is we have we can reduce the delta to 0.1. So that is I have we want to calculate number of steps. So I have 5 minutes and divided by 0.1. So I have to get the number of steps. So you have 5 divided by 0.1 is equal to 50. So 50 divisions are there. You have to make the calculations like you have done in the previous cases. So you have to start with the Q0. So then I have to produce up to 49. So total I will have 50 values. So after the calculation, so I will have the values. So theoretical value is 5, and Riemann value is 4.82. The error is reduced to this point only. So this is theoretical value, this is 5, and this is Riemann value is 4.80. And what is the error value? So the error is true error is 0.2. So again, it is confirmed that by increasing the number of intervals, number of steps, so we can improve the accuracy. The final thing is we can have the delta TS point. So with that we can calculate the volume. So number of steps is given by 5 minutes divided by 0.02 minutes. Okay. So we'll be having the each division. So each division we are going to. So totally I'll be having 250 divisions. So 250 divisions, and you can calculate the volume based on this. So cumulative volume based on this formula. Q1 is equal to plus dq by dt. So this is one part. So like this, you can go from Q0 to 0. So from that you can go up to 249. and after that you can calculate what you do. So 2 theoretical is 5, so 2 theoretical is 5, and you remember the get equals is 4, and 2 error is 1. So that is how we can confirm that by increasing the number of steps to do. So error is reduced in the